Guess what day it is? Guess what day it is? Hump Day! Yeah! I gotta pause it here for a second. Alright, so yesterday we did the Launcher Lab. If you are done with your Launcher Lab and want to turn it in before tomorrow, that's fine, we'll take it. Mr. Roth has a bucket, Mrs. Hill has a bucket, and I have a pile. Okay, so back there, if you want to turn that in today, that's fine. But those are due tomorrow. At Homer's, that is an email of the last 2 pages that you need to send us. Okay? If you were not here yesterday for the lab, then you are going to need to come in after school or on Friday and find one of us, and we will go over it and get you up to speed so that you can complete the lab. Okay? So we've got that going on for everyone. Okay? Looking ahead to today, we'll start with today. We are back in your blue packet, so you should have your blue packet and probably a calculator out. Doesn't matter what kind of calculator you have, but probably want a calculator too in your blue packet. Okay? We are going to do some more with polar type stuff today. Tomorrow we'll do some more polar graphing with that. And then this weekend there's multiple things that you should be doing for this particular class. First off, you should finish off the blue packet. Okay? That would be the first thing you want to do, including the last 3 pages. The last 3 pages are the review assignment that you're going to want to do this weekend. Okay? Because looking ahead, on Tuesday of next week is going to be your polar test in class. Okay? So Tuesday's polar test in class. Also this weekend we have some I think it's 1 or 2 brief videos to refresh your memories on complex numbers, because that's the next unit that we're going to go into is complex numbers. So we have 2 videos for you to watch, which we will post up on It's Learning probably this afternoon. Okay? So with 2 videos and the review to do in preparation for your test, which is next week, and then the next unit going from there. Okay? All right. So with that being said, we're actually going to start on, it's the page with the 4 polar graphs on it. It's got numbers 4, 5, 6, and 7 on it. We're actually going to start with number 7, but we're going to tweak it just a little bit. Okay? So first off, I want to remind you of what a polar coordinate is. A polar coordinate is of the form r comma theta, where r is the radius and theta is the angle. Okay? So again, we're thinking like Superman, not Batman. Batman is x comma y. Okay? So we go horizontally a certain distance, then we go vertically a certain distance, and that gives us our point. In polar, we have that distance that it takes to get from the pole to the point, and the angle, the trig angle to get to that. Okay? So that's what we're thinking. What I would like you in your neighborhoods to do is I would like you to find a partner, okay, and it can be a person at your table or somebody very close to you. Okay? You are going to come up with a radius and a theta. So you're going to give them the polar point. Okay? Their job is to graph it and give you the 3 other ways to do that particular, or to name that particular point. And then vice versa. So they're going to give you a radius and an angle. You're going to give them a radius and an angle. Okay? At Homer's, I'm going to place you guys in breakout rooms here momentarily. So in order to complete this. With that, okay, what did you have, my dear?
1 and then 90 degrees.
1 and 90 degrees?
Yeah.
Okay, that's fine. That works for me. So our original polar point was 1, 90 degrees. Okay? Right? So if I were to graph that one, that would be located right there. Correct? Okay? So I need a positive, which I already have. I need a positive, negative. So the same spot would be positive 1, negative 270 degrees. With me? Because I would start here, would be my 0, and then down here would be my negative 90, negative 180, negative 270. Okay? Because we went the negative direction around the unit circle. Okay? Then I need a negative positive. So a negative positive would be negative 1, positive 270 degrees. Because I would need to be going straight down, but then I would go the opposite way through the pole because of the negative R value. Okay? And then I need a negative, and that would be negative 1, negative 90 degrees. Okay? On those. Okay? Any questions on that little activity? Okay? Love it. So, what we would like to be doing today is we would like to talk about first changing back and forth betwixt the different forms, and then I would also like to start some graphing today. Okay? Okay? So if I have just a regular old point somewhere in space, okay? That point can have a rectangular x, y address, location, if you will. Okay? And so that would be, we would go x this way, y that way, and we would get that location in space on the Cartesian plane. Okay? In polar form, that would be r, theta, where we would go directly to it with a length of r and an angle of theta. Okay? Converting back and forth between those two. So if I'm going to go from polar to rectangular. Okay? So I have my r value, I have my theta value. I need to know what x and y are. Okay? What I'm going to do there then is x is equal to r cosine of theta, and y is equal to r sine of theta. So if I have my polar point, to get the rectangular coordinates of that point, I take my r value, multiply it by the cosine of my angle. That gives me the x. I take my r value, multiply it by the sine of theta. That gives me my y. That gives me my x. Okay? Very easy to go polar to rectangular. Okay? Rectangular to polar is a little more involved. Okay? But it's nothing that you haven't seen this year already. it's vector math again. Okay? Where the r value is going to be the square root of the x part squared plus the y part squared. That's going to give you your r value. Your angle is actually going to be your reference angle. Theta prime is going to be the inverse tangent of y over x. Remembering that we drop the negatives. Okay. Then you're going to have to adjust that for whichever quadrant theta is in. Okay. Remember, your reference angle always comes off of the horizontal. Okay. So if we're in quadrant 1, our reference angle is our angle. If we're in quadrant 2, our angle is 180 degrees minus the reference angle, or pi minus the reference angle. In quadrant 3, it's 180 plus the reference angle, or pi plus the reference angle. In quadrant 4, it's 360 minus the reference angle, or 2 pi minus the reference angle. Okay, so we check our quadrants there. Okay? All right. So let's do a couple of these right now. So first one that I want to do, I'm actually going to do, this is, now we're in our packet. Okay? I'm actually going to do A and C first, and then I'm going to have you do B, D, E, and F. Okay? So we want to change the point to the other form. So the very first thing that we need to figure out is we need to figure out which form our current question is in. 3 comma pi over 2. Is that a rectangular or a polar point? Why polar? Because the pi over 2 is an angle. It's a common angle. So this is in polar. So to switch it to rectangular, we would say then that x is equal to r cosine theta, or 3 cosine of pi over 2. Cosine at pi over 2? Zero times 3? 0. So the x part is 0. Then we have to figure out the y part. Our sine of theta, 3 sine of pi over 2. Sine of pi over 2 times 3? 3. So the rectangular point for this same location would be 0, 3. So if you look like you got a little question going on inside the, in betwixt the ears. Okay. Okay. Anybody? Okay. Let's look at C. C. Polar or rectangular? looks rectangular to me also, because I don't see any angles, degrees, or pies for that matter. So we need to first figure out our R value. R is going to equal the square root of x squared plus y squared. So that is going to be the square root of 3 squared plus 1 squared. Square root of 3 squared is 3. 1 squared is 1. 3 plus 1 is 4. And the square root of 4 is 2. Okay. Then we need to find our reference angle. Theta is going to be the inverse tangent of 1 divided by the square root of 3. One divided by the square root of 3, an inverse tangent to size gets me, anyone? It is on the unit circle. 30 degrees? Yep, gets me 30 degrees. You got it last week, Wednesday, probably.
I didn't see it in my
Oh, okay. All right, that's fine. We have another one. We got after. Okay. Which quadrant is this particular point in? Quadrant 1, because it's positive, positive. So that means our reference angle is, in fact, our angle. Okay? So the polar point here then would be the point 2, 30 degrees. We would also accept 2, pi over 6. Okay? What I'd like you to do now is I would like you to do the other 4 on that page. B, D, E, and F. So B is 6. So for letter B, I get the point 3 square roots of 3 over 2, 3 halves. Yes? Yeah. For letter D, I get the radius is 2 square roots of 2, and the angle is 315 degrees. Yes? Questions, comments, concerns? None? Okay. E is in polar, so we need to put it into rectangular. Decimal places, 7, 7. 2 decimal places, 8, 5. Yes? No? People got something different there. It's okay to get something different here. Everybody got those? Jazz, why didn't you get them?
I forgot how to change it
From radians to degrees? Yeah. There's two ways that we can do that. Okay? So you're probably going to get different angles here because your calculators are all in degrees. And if you just type in 5 pi over 8, that's in radians. So you got to do one of two things first to get these two answers. First, you could convert 5 pi over 8 into degrees, okay, by multiplying by 180 and dividing by pi. Okay? That's one way. Other way is just change your calculator from degrees into radians. One of those two. Okay? That's the most common mistake here in polar coordinates, is that your calculator is in the wrong mode. Okay? So you need to fix that before you got to, each problem. If it's in degrees, make sure your calculator is in degrees. If it's in radians, put your calculator in radians, okay? Or convert it to 2 degrees. One of the two. Yes, bitch. Okay, so then R here is going to be the square root of negative 3 squared plus 5 squared plus 5. That's going to be square root of 4. Yep. And then our reference angle is going to be the inverse tangent of 5/3, which is going to be 59 point. Because we are in quadrant 3, our actual theta is 180 degrees plus our reference angle. So in this case, it's going to be 239. Yeah. So our polar point here would be the square root of 34, comma, 239.04 degrees. Okay. Wonderfulness there. Okay. So let's dive into some graphing now. We'll start with some easy graphs. My plan is to do those 6 graphs on this particular page in your blue packet today. Tomorrow we'll pick up with graphing on the next pages because those are a little more complicated type graphs for us to be doing. Okay? So what this is saying in this first problem. is this is telling me that we want all of the points two units away from the pole. Okay. Remember, the pole is the center of the graph. Okay. So we want all units or all points 2 units away from that. Well, here's one that is 2 units away. Here is one that is 2 units away. Here's one 2 units away. Here's one 2 units away. Here's a bunch more, all 2 units away. So these are equal graphs give us, oops, cut it short there, produce circular graphs in a polar coordinate system. Okay. Number 2 then is saying we want all of the points -3 units away. Well, remember, in a polar graph, if I start at 0 degrees, r equals -3 would actually be right there. If I go up to 90 degrees, r equals -3 would be right there. If I go out to 180 degrees, r equals -3 is right there. And if I go down to 270 degrees, r equals -3 is right there. So it still is going to produce for us a circle. If we were tracing it, we would start on the opposite side that we would normally start on. Okay? So r equals graphs. Are circles in polarness. Theta equal graphs. Okay? So what this is saying is we want all of the points that are on an angle of 120 degrees. Off of the polar axes. So you would find 120 degrees and you would draw a line through that one. And that line then is, it produces a skew line. So we would need to find negative 120 degrees here on this next one. So here would be 0. Here would be negative 90 degrees. So this one over here would be negative 120 degrees. And that would then produce our line. Love it. Love it. Now, these next two, we might have to do a little math to go along with them. So, first up, cosecant. We haven't seen cosecant in a while. What is cosecant the reciprocal of? Which trig function? Sine, right? Okay. Sine, yep. Because everything needs a co. So this is really r equals 2 over sine of theta. Now I can multiply both sides by sine of theta. And that's going to give me r sine of theta equals 2. Where have I seen r sine of theta before? We've seen it today. But what is it? R sine of theta is the same as y. It's y, right? Because earlier we said y equals r sine of theta. Well, if r sine of theta is equal to y, then I could just say that this is y equals 2. In a Cartesian system, XY graph, what does y equals 2 graph out to be? It's a line. What kind of a line? It's horizontal because it's y equals, right? So this would be a horizontal line right? 2 up from the origin, right? Well, on a polar graph, we're going to have a horizontal line. 1, 2. Oops, I way missed. 2 up from the polar axis. Okay. So r equals -3 over cosine. Multiply both sides by cosine. Gives me r cosine of theta equals -3. R cosine of theta is x. So this is x equals -3. X equals -3 are what kind of lines? Vertical lines. Yep. And so we would go vertically -3, 1, 2, and 3 from the pool. Okay. Questions, comments, concerns, clarifications on today? I remind you that your labs are due at some point in time. You don't have to throw stuff at me, Carly. Or due at some point in time in the next 24 hours. Okay? If you haven't done and want to turn it in, the piles are back there. You can definitely throw it on the pile. At Homers, please remember that you need to email your grading teacher, which for this case, for you, that's me. Email me with your the last pictures of the last 2 pages.